So this is lesson 7.7, and this is intermediate algebra, linear inequalities in two variables. Alright, so what we've done in the past, when we've graphed, we have given you an equation of a line like 2x plus 3 equals y, and I want you to find the x and the y value, and you were able to get a line, because that's a linear equation. Alright, so what we're going to do here is, instead of getting a line, we're going to look at all the different solutions, because right now the way that you have done these is, when you have an equal sign here, that means you're going to get a line, and every x and y value that you plug in to, say, a table that looks like this, every number is going to fit on that line here. Okay, because of this equal sign. Now what we're going to do is, I'm going to take something like this, and I may say greater than y, which means I am not going to get a line any longer because there's no equal sign. I'm going to get a whole bunch of numbers below the line, or a whole bunch of numbers above the line. And that's what we're looking for, is what are the possible answers that we're going to get. And the line then does not become our answer, it becomes the boundary. And that's what we're going to look at in this lesson. So we are going to jump to example number 2, and it says y is less than 2x minus 3. Okay, so what we're going to do here is we are going to graph this line as if this was an equal sign. If it were an equal sign, we would get, and if you remember, y equals mx plus b is the slope-intercept form of the equation, where the m is the slope and the b is the y-intercept. So we can just graph that pretty quick. Let me get a graph here. And our graph is going to be, our y-intercept is -3, so it's going to cross y at -3. And my slope is 2, which is 2 over 1, which is y over x. So remember, I start at the y-intercept, and I go up or down 2, left or right 1. So I'm going to go up 2, use yellow here, over 1. Up 2 over 1. And that gives me, if I connect the dots, that gives me the equation for this equation right here. But because it's not an equation, because it's an inequality, things are going to be a little bit different. Because there is not an equal sign, remember, this can be less than or equal to. Because it's not an equal sign, this is not going to be a solid line. It's going to be a dotted line. So what I'm going to do here is make my pen thicker so you can see the line, and I'm also going to change that yellow to red and make a dotted line. Okay, so it goes through all those points, but it's dotted because it cannot be on the line, because it says y is less than. It does not say it's equal to. So without that line underneath here, like you're used to seeing sometimes, if that line were there, it would be a solid line. But because it's not, it's going to be dotted, meaning that the points do not fall on the line. So what we're going to do now is shade. So we need to decide whether or not we're going to shade everything down here or everything up here. Alright, this is how we decide that. We take our original equation, and we just take a number over here somewhere. Okay? Doesn't matter which one. Let's take the number 1, 2, 3, 4, 5, 0. That point is on the right of that line there. So we're going to take the point 5, 0, and we're going to plug that in. 0 is the y, 5 is the x, and we're going to see if that's a true statement. 0 is less than 7. Is that a true statement? Yes, it is. if it's a true statement, that means everything over here is going to make the answer a true statement. So we shade that side. If we were to pick a point over here, let's say we picked 1, 2, 3, 4, 5, negative 5, 0. Let's plug it in here and see if we have a true statement. We'll do this in red. 0 is less than 2 times negative 5 minus 3. 0 is less than negative 10 minus 3. 0 is less than negative 13. Is that a true statement? No. So nothing gets shaded in on that side of the line. Okay? See how that works? So we take our original equation, or inequality, make it into an equation by changing the greater than or less than sign to an equal sign. We graph the line. We determine whether it's dotted or not based on whether this is a less than or equal to sign, or a greater than or equal to sign. We determine whether it's solid. We draw it either solid or dotted depending on what we're given up here. Then we pick a point over on this side and plug it into the original and see if it's a true statement. If it is, we shade this side. If it isn't, we shade the other side. And that's pretty much it. Alright, so let's get rid of all of this stuff. And we're going to jump to example number, let's see, 3. Now let's do example number 4. So I'm going to move this out of the way for now. And again, get me a smaller pen. So we've got y is greater than 1/4 x. Since there's no equal sign underneath that inequality sign, we know our line's going to be dotted. And we're going to write this as an equal so that we can draw our line. And if you want, you can put an x and a y here. And we can put a 4 in for x. 4 times 1/4 is 1. We can put an 8 in here for x. 8 times 1/4 is 2. We could put a negative 4 in for x, and we get a negative 1. Okay, so I can do it that way. Or I can write it as y equals 1/4 x plus 0, and that's in my form y equals mx plus b. And I know my y-intercept is 0 and my slope is 1/4. I mean, either way works. Whatever way you want to graph this is kind of up to you. Alright, give myself bigger, and we'll use red to draw our line. So 1, 2, 3, 4, 1. 5, 6, 7, 8, 2. Negative 1, 2, 3, 4, down 1. Okay, so I get a line that looks like that, but because of the symbol, whoops, wrong color, because of that symbol not being an equal sign, then I have to, I don't know if I can even do that now, probably can't even, oh yep I can, this is going to be dotted. Okay, so that's a dotted line. Now I just need to know whether my answers are above or below so I know what to shade. So I'm just going to pick a point. It doesn't really even matter what point you pick. Let's pick this point right there, and that is 3, 1, 2, 3, 4, 5. So let's plug 3 and 5 into this original equation. 3 is the x, 5 is the y. So 5 is the y is greater than 1/4 times my x, which is 3. Is 5 greater than 3/4? Is that a true statement? Yes, it is. So that means everything above the line is going to be shaded. If it were a false statement, then everything below the line would be shaded. But it's a true statement, so that would be our answer, shading everything above the line. And that is it for 7.7. I'm looking at the problem set real quick to see if there's anything weird in here. 1 through 36, what we just did. 27, 41, 43, 5, 47. Okay, to 51. All right. So 47 to 51 is just review, where you're just solving for the inequalities. So nothing new there, but it's just old stuff. So you might have to look back in your notes in order to do that. But other than that, it doesn't look too bad there.